Okay, so now that you understand the difference between a property and a theorem, right? And we've already discussed theorems involving quadrilaterals and parallelograms. That is, if you are given a quadrilateral, how can you prove a quadrilateral to be a parallelogram? We've talked about that extensively. We've learned 3 proofs, and there's 2 other ways that we've learned to prove that a quadrilateral is in fact a parallelogram, right? So let's go there. Right, there's the 3 ways. We've learned 3 proofs, 3 formal proofs, and there's 2 other ways that we can prove a quadrilateral to be a parallelogram. But now, what about the other shapes? What if I'm given a parallelogram and I need to prove that this parallelogram is in fact a rectangle? Or if I'm given a quadrilateral and I need to prove that this quadrilateral is in fact a rhombus? Because remember, I could be given the shape in the paper. Listen to what I'm saying. I could be given the shape in the paper. But if the examiner tells me that the shape is a quadrilateral, then we have to believe it, right? We have to prove that it's a rhombus because we are told that it's a quadrilateral and not a rhombus, right? And so now what we're going to learn now are basically just other theorems that we can use to prove how a quadrilateral can be in fact a rhombus, or how a parallelogram can in fact be a rectangle, right? And we don't learn proofs for them, we just take them as facts. Yeah, so that actually lightens the work for you guys because you don't have to learn proofs, right? You just go straight to the theorem and you make use of it, right? So you'll only be using the theorem, you don't need to prove it, right? When you're proving quadrilaterals to be parallelograms, then you could either be asked to prove the theorem or you would be required to use the theorem. So keep that at the back of your mind. So let's go through this list and see exactly what we can learn from this. Right, so you need to keep this diagram at the back of your head, right? You have to keep this diagram because it's the only way I can explain it. In this diagram here, I've showed you how every shape develops from other shapes. So I showed you how the parallelogram develops from the quadrilateral. I showed you how the rectangle develops from the parallelogram, but the rectangle can also develop from the quadrilateral because if it goes from here to here, then it can go this way, right? I showed you how the rhombus can develop from the quadrilateral to the parallelogram to the rhombus. Now, why this is important? Because you will see exactly when I read this how I'm going to read it. Listen to this. If we prove the following, and you see I'm using if and then we can conclude that a parallelogram is a rectangle. And so what we can say is, if you are in the paper, if you are given this diagram, they call this diagram a parallelogram, then all you need to do is just prove that one angle is equal to 90 degrees and then you have this to be a rectangle. If they tell us that this diagram here is a parallelogram, then I just need to show that the diagonals are equal and then I can prove that this parallelogram is in fact a rectangle. However, listen to this. If they call this diagram a quadrilateral, right, then if I want to make use of these theorems, I first need to prove it to be a parallelogram. Then I have to show that one angle is equal to 90 degrees to get to this, right? Let me say that again. If they call this a quadrilateral, so they're calling it a quadrilateral, and I want to make use of one of these theorems, I have to first prove that this so-called quadrilateral is a parallelogram, then I can use these, right? But let's say that they call this diagram a quadrilateral, so they're calling it a quadrilateral, then I can just show that the diagonals are equal and bisect each other, and then I can just bypass the parallelogram and go straight to proving that it's a rectangle. So you need to be very mindful when you're working with these things, because see this parallelogram rectangle, quadrilateral rectangle, they can do whatever they want, right? They can do whatever they want. So maybe in the paper they could call this a quadrilateral, they could call it a quadrilateral, but the only way to prove that this quadrilateral is a rectangle is by showing one angle is equal to 90 degrees. The fact that they call it a quadrilateral means you have to first prove it to be a parallelogram in order for you to make use of the one angle equal to 90 degree theorem, right? So you need to work, you have to be very strategic when you work with this. It seems complicated, but if you learn these theorems, it will not be complicated. Right, let's go here with this one. If we prove the following, then we can conclude that a parallelogram is a rhombus. So if in the paper they give you this diagram here and they call this diagram a parallelogram, if I can prove on this parallelogram, so-called parallelogram, that a pair of adjacent sides, so this is one pair, this is another, I just need to show that one pair of adjacent sides are equal, then I can say that this so-called parallelogram is in fact a rhombus. Or if they give this diagram in the paper, they call it a parallelogram. If I can prove that the so-called parallelogram has diagonals that bisect at 90 degrees, then I can say that this so-called parallelogram is in fact a rhombus. However, they can go a bit more complicated. They could give this diagram in the paper and they could call it a quadrilateral because it's a four-sided figure, right? Everything's stemmed, it stemmed from there, so they could call it a quadrilateral. If they call it a quadrilateral, then you have to first prove it to be a parallelogram, then prove it to be a rhombus. How? You can, after first proving it to be a parallelogram, you can make use of these theorems. Right, let's go here. If we have the following, then we can conclude that any of the quadrilaterals is a square. We can say that a square is a parallelogram with an interior right angle and a pair of adjacent sides equal. So if you're going to prove a square, right, let's say in this paper you're given this diagram and they call this diagram a parallelogram, then you need to prove two things. You need to prove one interior angle to be 90 degrees and you need to prove that a pair of adjacent sides are equal. Then you can call the so-called parallelogram a square, right? Alternatively, they could give you this diagram in the paper and they could call it a rectangle. If you can prove that a pair of adjacent sides to be equal, then you can say that the so-called rectangle is in fact a square, right? They could give you this diagram in the paper and they could call it a rhombus, right? If they call it a rhombus, then what you just need to do is you can prove that one angle is 90 degrees and then you can prove that the so-called rhombus is in fact a square. They could give you this diagram in the paper. They could call it a rhombus. If you prove that the diagonals of the so-called rhombus are equal in length, then you can say that the so-called rhombus is in fact a square. Right. But the point that I'm trying to make here is in order for you to make use of, let's say, this theorem here, you have to first prove it to be a rectangle if you're not told that it's a rectangle. In order for you to make use of this theorem here, you have to first prove that it's a rhombus in order for you to make use of this theorem. Let's say that they tell you that quadrilateral is a parallelogram, but the only way to prove that the quadrilateral is a square is by first proving it to be a rhombus and then proving it to be a square. The way you do that now is to first prove that it's a rhombus, the so-called parallelogram is a rhombus, and then prove that rhombus to be a square. Right? That's all you got to do. So you just got to keep this network in your mind. Keep this network in your mind, how everything just develops from the top coming down. Right. If we have the following, then we can conclude that any of the quadrilateral is a trapezium. Right. So let's say that you have a quadrilateral, some random quadrilateral. Right. If you prove that one pair of opposite sides are parallel, then automatically you have a trapezium. Very simple. And with a kite, it requires a bit more of thinking. If you have the following, then we can prove that any of the quadrilateral is a kite. Right. So let's say you have a random quadrilateral. See, I didn't name what quadrilateral it is. You just have a random quadrilateral. If you can prove that two pairs of adjacent sides are equal, then you can prove that the quadrilateral is a kite. So let's say you just have a random four-sided figure. If you can prove this pair, so that's an adjacent side, and this pair here, that's another pair of adjacent sides to be equal. So you proved two pairs to be equal, then you can prove that the quadrilateral is a kite. Or if you can prove that the diagonals intersect at right angles and the longer diagonals bisect the shorter diagonal. So if you prove that from this, let's say they call this a quadrilateral because it's a four-sided figure. See where it comes from. It comes from a quadrilateral, so it can take that name. So let's say that you proved that this diagonal here and this diagonal here intersect at 90 degrees, but you also need to prove that the longer diagonal bisects the shorter diagonal, so it cuts it in half. What did we say the longer diagonal was by definition? We said draw your adjacent sides, so that's one pair of adjacent sides. This is another pair of adjacent sides. The line that is in between them, this line here, will be the longer diagonal. Right? That was by definition, that's what we call it. Or alternatively, can you see, this is why I put an arrow here, right? So what we can say is, if you're given a rhombus, right, and you prove two pairs of adjacent sides to be equal, then you can say that this rhombus is in fact a kite. Let me say that again. If you're given a rhombus, so they give you this diagram here in the paper, they call it a rhombus. If you can prove two pairs of adjacent sides to be equal, then you can say that that rhombus is in fact a kite. So two pairs of adjacent sides will be, this is one pair of adjacent sides. This will be another pair. So prove that two pairs to be equal. Then you can prove that the so-called rhombus is in fact a kite. And a rhombus with a longer diagonal bisecting the shorter diagonal. So that means the longer diagonal cuts the shorter diagonal in half. So if they gave you this diagram and they called it a rhombus, you can prove that this so-called rhombus is in fact a kite by showing that the longer diagonal bisects the shorter diagonal. And I've already talked about the definition of the longer diagonal, so you know where to locate the longer diagonal. Now, that's everything that you need to know. Everything that you need to know on the theorems. Right? So it's a bit complicated, but if you study it and you understand when to use properties and when to use theorems, then you'll be good with geometry. Right.